Welcome, guys, to another episode of Ground Control to Major Nerds. Today we have something quirky, something interesting, something I think we will learn from. And we have our constant co hosts back. We have Ashwini back again from our previous episode, who he was missing because of his personal reasons. So we have Ashwini, we have Parvesh back, and myself, Shri. Today's episode is going to be a bit interesting about we're going to be deep diving into drones. That's what Ashwini works on mostly. So we're going to be making it centric to that. And since our channel name is Ground Control to Major Nerds, we're going to make sure that we talk more about what is ground controls in terms of drones and UAS, unmanned aerial systems, or unmanned flying systems, anything, unmanned machine systems. Basically, we're going to talk more about ground systems. So without further ado, let's introduce our hosts. Ashwini, how are you doing?
Hi, glad to be back. I had major FOMO. I saw your last episode, saw all the reactions, and I was like, I should have been there. But
We will actually capture some of your reactions too before we get into the topic today. So yeah,
right. But yeah, glad to be back, and really looking forward to talking about ground controls, being part of ground control to major nodes.
nice.
So give us a reaction phase for this thumbnail, this video thumbnail.
A reaction phase.
No,
Yeah,
it's okay.
Give us
Let's not do that. We are not into the clickbaiting YouTube.
Yeah.
We are
So
we did it
hardworking
last
YouTubers.
episode.
Let's not get our secrets out there.
Yeah, exactly. All right. On to the next host. Parvesh, how are you doing?
Good. Hi, I'm Parvesh, business analyst and gaming and anime expert.
How is your week been? Still the same?
I got
Any
a few new
updates?
games to play,
Oh, okay.
and I'm
Other
learning
than
Python.
oh, cool. Anything
How
else?
does that make you a horse trainer?
Horse trainer. Don't worry about that. That's an Easter egg for the gamers.
Okay, fine. So all right. So circling back to the last week's topic really quick. So Ashwini, you saw our episode. You saw the videos that we posted. What is your reaction on the launch, especially from my front yard that I posted, and
Yes.
the docking, and also the mid-flight, mid en route to the ISS, basically the video that they posted. What do you think of the overall experience that the AXPO crew had?
It very much felt like I was part of the entire journey. This is probably one of the first times I have followed this entire event from the very beginning, all the way from interviews that these guys did before they went for their launch, right down to the entire countdown sequence, the entire launch. I saw the video that you posted from outside your house, and I saw the entire live video on YouTube. It just felt like I was part of it, and this is what I was talking about when we did the episode, that there is such a connection that we have to this entire event. And when these guys docked, it felt like a success for me. And even though I have absolutely nothing in relation to this mission, it still felt like a victory for me. And just seeing the reactions of the guys the first time that they enter the ISS, it was just such a wholesome and complete feeling. And great job to the entire team for putting 4 astronauts back on the ISS, 3 completely new faces. And I hope they're having all the fun and doing all the cool experiments as well. But most importantly, learning everything, especially for our Indian representative, doing a lot of learning so that can be transferred onto ISRO's Gaganyaan program. So yeah, all the best to these guys.
Nice. Yeah. I think
Another important question. Did that scene where the booster fell off look like Winamp to you?
Look like what?
Winamp visualization.
It actually did. In fact, the video Shrikant posted Even on that video, very clearly you can see that. And I was just like, what is this? Why does this look like I need to put some synth beats into this? Very accurate observation by you, Parvesh.
Wow. Maybe I was the only one who did not feel that way, but okay.
That's because you're
Back-to-back
old.
Winamp episodes.
Yeah. All right. So let's dive into our topic for today. So ground controls. I'll actually start off first. Just to mention. So I have always like been fascinated with drones and the drone technology. Growing up, obviously that was the buzzword, like getting into engineering, doing projects about drones or anything specifically to drones, like the passive radars, for example, like trying to see how uh, drone surveillance could be done, or how like communication protocols to communicate to drones could be done from the ground stations or from any other platform, basically. So those things have always been like buzzwords, but now they're becoming reality, right? So things are getting done right now in the industry where, uh, critically, like military side actually is doing more than the civilian side, but also civilian, developments are also happening in this. So it's very exciting time. At the same time, I have been disconnected because I've been more on the aviation side, aviation safety side, or aviation R&D side. So this is one of those experiences where maybe there are very many parallels between the aviation and the drone side, but at the same time, the techniques and the protocols, like the protocols are not that different, right? So they don't vary that much. So with that said, I think I would like to start off, Ashwini, like how would you describe what a ground station is for the drones or for any unmanned systems?
Right. So what you rightly said was that ground control stations is not something that is only for unmanned systems. A ground control station, simply put, is the brain on the ground that controls and communicates with any system. It can be a manned or an unmanned system, or it can also be something that is an interstellar thing, like something that's based in space. It could be a manned mission that's out in space or a satellite. For today's topic, as I just said, it's got a huge scope. So I want to narrow it down only to drones today, and that is why what I'll tell you today is that a ground control station, specifically for drones, is an interface between a human operator that's on ground and a remote vehicle that's up in the air. And if you can imagine a drone flying overhead, uh, the GCS or a ground control station is where all of its decisions, commands, monitoring, and data exchange happen from. At the most basic level, a GCS sends commands to the vehicle, like where to fly, how fast to fly, when to take a photo, when to return to its base. And at the same time, it is also receiving telemetry data from the vehicle. That includes states like its location, its speed, its current battery status, and also accurate sensor data. You can think of it as a two-way pipeline of information. So that is what a GCS is. Now, one very important thing that we need to consider is GCS setups can hugely vary depending on what the applications are. This is what I'll get into slightly later into the podcast. But GCS setups can be as small as a cell phone in your hand, and it can be as large as a huge room with multiple monitors. So, in general, a ground control station can be anything as long as it is an interface between a human that's on the ground and a system that's in the air.
Cool. So let's talk about it in this way, right? So you spoke about the two-way pipeline, right? So how do you determine like what should consist of that two-way pipeline, basically, right? Like how do you guys figure out like this is what should be there in that two-way pipeline? Like is it due to the mission scope that you guys decided, or is it like something which by default it should be there no matter what for just the operation of the UAS?
Right. Very valid question. The right way to approach this is to understand what is the function of a GCS. So, excuse me, what we mostly need to understand is, as a person on the ground, we need to have control over the flight, whether that is a manual piloting or it's a waypoint based navigation system. What we need to understand is we need to define, or from ground, what is the motion, where is the aerial system going to fly. So that is one of the most important things. That's flight control. The second most important thing is sensor management. It is very important to control the onboard sensors, such as cameras, such as radars, such as LiDAR systems. The data that is coming from that needs to come onto the ground as soon as possible, so that any monitoring that is happening can happen in real time. The third part is safety monitoring. We need to get alerts on battery status, whether it is low, whether there is enough battery, whether the signal strength is good enough so that there is no loss of signal, and there is no flight envelope violations. We need to always ensure that there is safe operation of the drone. And finally, there has to be communication management. You have to have a choice of what frequencies do you want to communicate with the drone, whether this is on radio links, whether this is through SATCOM, or it's using cellular networks. So these are the functions of a GCS, and that is what determines what is going through this two-way data pipeline.
So if you're using cellular networks, right, there's always a risk of hacking, right?
Right. Absolutely, there is, which is why we will later cover this again, but I will mention it right now as well. Most of the times, communication that takes place between a ground control station and an aerial system is done by an encrypted channel. In the industry, currently we are looking at systems following AES 128 or AES 256. These are encryption protocols that are readily available. One of the most common brands of ground control stations that are used for smaller drones is by a company called HereLink. And HereLink has AES 256 available as encryption. So hacking is something that may still happen, but the encryption does allow you to get a lot of protection. A more common thing would be jamming or spoofing that would be able to affect the communication between our ground control and a drone. But that is something that we can get into a later episode.
Got it. So let's talk about the antenna systems, right? Like, is that something that is like readily available off the shelf? Is what is used or utilized, or are they like custom antennas that need to be developed or designed for the specific, like, UAS system that you need to make a ground station for?
Excellent. Again, we are getting into the parts of a ground control station.
Yeah.
So antennas are one of the most critical components in any ground control station. But this will form your communication system, right? The communication system is the heart. It is the link between the vehicle and the ground. Depending on the platform, you could consider that this would consist of RF modems for drones which are flying within the line of sight, or this could consist of SATCOM communication for BVLOS, which is beyond visual line of sight, right? And now all of the communication between such applications could be encrypted, like I mentioned before. And the most important terms before we get to the antennas in this, we have to understand is uplink and downlink. Uplink is what is sent from the ground control station to the drone, and downlink is something that is received from the drone to the ground. So like I mentioned before, any signals, any commands that are to be sent, they are uplinked from the ground control to the drone, and any telemetry data is downlinked from the drone to the ground control station. So antennas, one of the most common antennas used for smaller drones, for drones in visual line of sight, you will see these really small antennas coming out. So those can be the ones used. For the longer ones, you are going to use antennas such as LoRa antennas, which are able to do much longer ranges. And for beyond visual line of sight, where you're doing really long communication, these are done through satellite communication.
Got it. So the parallels over here are obviously the SATCOM, right? With aviation, for me to ask this question, right? So one of the biggest things about the SATCOM is like it even though it's like a low criticality system for an aircraft, it is still something which does critical communication or non-critical communications, but also major communications for the aircraft. Now, one of the things is like we on the aviation side try to link up with the LEO satellites or the GEO satellites, depending upon what kind of files are being sent and what kind of data is being sent. So for drones, what are the most common data links that need to be like communicated? Is it like depending upon the mission that changes? Like for example, if it's a surveillance mission, then do you guys use a geo satellite to have huge dumps of data going through? Or is it like no matter what, you guys have your own constellation of satellites that you have to subscribe to and then use that for your downlinks?
That is a really loaded question, and I will not be able to give you a very accurate
Okay,
data
got it.
answer on what satellites we use. What I can tell you is, as someone who has worked mostly on drones with that travel within the line of sight,
Mhm.
we completely bypass satellites because
Got it.
communication from an aerial vehicle to ground is much easier than bouncing it off a satellite. I am yet to work on drones that are operating on different continents, or these are called hail drones, high altitude drones.
Got it.
So I am yet to work on such drones. I work on slightly smaller surveillance type drones
Got
and
it. But
payload drones.
then let's talk about the data like downlink, right? Between like in visual line
Right.
communications. Like then do you guys have to do like a lot of data processing for the data to be communicating from the UAS down to the ground station? Or do you guys have already set up a protocol, or is it mostly usually a protocol that's already set up to have low latency data going across?
So the low latency is definitely one of the things that you would want in all the drones. But like you previously mentioned, it really depends on what sort of mission you're doing. One of the missions that we had made a drone for was doing surveillance and identifying humans on ground. This was supposed to be as part of evacuation and danger assessment in an area that has likely been hit by a flood or an earthquake or a landslide. So a drone just flying overhead is able to look at the ground, use artificial intelligence and machine learning to identify humans just through various parts of the body. So in this case, you would want that a lot of the processing is done on the drone itself, because
Oh,
sending data back to ground and then identifying using ground computing would there would be a lag, and the drone might overshoot after recording some sort of data where a human is. So you would want a lot of processing to happen on the drone itself. But
hmm.
on the other hand, a completely different example of using an agricultural drone for just spraying. In this case, you really don't need a lot of processing on the drone. You can have all of the processing on ground where you give fixed waypoints before the drone has just flown off. And then using those waypoints, the drone is just flying a fixed path and just spraying water or pesticide. So it really depends on what mission you're in.
Yeah, that's what I was trying to like get to. Maybe I was not clear with my question, but yeah. So, like, is the processing mostly done on the drone, or it's mostly done on the ground station? I think that answers the question. So, depending upon the mission requirements and the mission scope, I guess that's where there is different processing powers on the drone or on the ground station. Then, got it. Okay. So, yeah. The other thing is like when you're trying to design a ground station, or when a ground station is like required, um what are the different like parameters or specifications that are looked at? Like for example, uh, there are ground stations which can be like mobile, right? You can just take the drone, take the ground station with you, and then start it off. Whereas there are like a truck, like a like a ground station which is as big as a truck, and or as a room somewhere remotely kept, and then the drone just flies, and the operator is sitting in one location and flying. So how does that vary? Like why are not like there's only one way of ground stations for every single drone system? Obviously there'll be drone systems which are doing beyond visual range missions, and that may be what like a remote location could be. But like why is there so many variants of different types of drone like ground control systems for drones?
So you can look at it as a modular design, and you're scaling up the modular design purely based on function. But Getting into the modular design, let's just define what the parts are. And when you understand what the different parts, essential parts of a ground control station are, then we can try to understand the answer to this question. So the first and the most important part of any ground control station is the command and control interface, or we call it a C2. This is the operator's cockpit. This is the place where there are screens, there is software, there is a keyboard, there are possibly joysticks, there are touch screens which have buttons on it. And these are all used to send commands to the vehicle and monitor the state of the vehicle. This is where you plan your mission. This is where you have control inputs like taking off or landing. And this is where you monitor the flight status in real time with states like altitude, GPS location, and battery. The quality of this interface can make or break this mission, and a good UI UX or a good user interface will mean that there is a faster response and fewer operator errors. So this is one of the most critical parts in any ground control station. On a drone, like a hobby drone, most common example, a DJI drone, you do not need a very advanced C2. You can use a mobile screen with very basic functions. But on the other hand, if you have something like an MQ-9 Reaper, this is where you need an entire command center with huge rooms because you have multiple payloads, you have multiple states, you have a drone that's probably flying on a different continent. So this is where you need to massively scale up your command and control interface. Getting to the next part, this is what I had previously mentioned, which is a communication system where you can use radio frequency or SATCOM communication, and your uplink and downlink exists. I'm not going to get into it again. The third and the most important part is telemetry and data processing. On any vehicle that is sending data back to you, the GCS's role is to interpret the data and show it as visual data to an operator so that the operator doesn't have to go through code. The operator has to see something physical. So real-time telemetry, such as position, speed, altitude, can be shown on maps. Payload data can be showed as images, videos, or sensor measurement. And health diagnostics, such as engine temperatures, signal strengths, battery voltages, motor RPMs, these can also be shown as graphical data. Some ground control stations, typically really advanced ones, also have built-in analytics through artificial intelligence, where missions are run repeatedly and those are taught to an AI. So an AI understands what normal functioning is. So any outlier is interpreted by the AI and immediately reported to the ground control. So these anomalies, such as unusual battery voltage drop, unusual wind shear, or approaching restricted airspace, which would mean that you're flying outside of your flight envelope, these can immediately be highlighted to the ground operator. So this is very important. Finally, one of the things that we really overlook is safety and fail-safes. Every GCS should have safety protocols. One of the most common protocol that is used by most drones is something called geofencing, where you define an area where a drone cannot go. To all the gamers in our video, this is an area that of a map that you currently cannot access because you may have not finished missions in the previous phase. So you sort of hit a dead zone where you cannot enter. This is exactly what geofencing is like. Me as a ground controller has defined your flight envelope and you just cannot go beyond this. So that is very important so that the drone does not go into an area where it is restricted.
Okay,
Apart from
so I have a
this,
question here.
yes.
But that's not something fully under control, right? Let's say your drone is moving really fast
Yes.
and there's wind behind you, which pushes you outside the envelope. What happens then? Does it just turn around and come back?
No. Geofencing is done via GPS. So you are essentially defining a GPS code where a drone cannot go. Now, every drone has an autopilot system, which is continuously assessing GPS coordinates, the current state of the drone. So if a drone happens to go into a restricted area, its own onboard flight computer will take remedial measures for the drone to come back into an area where it can fly. Even if you repeatedly try to give manual control, wind is an external factor. Wind will definitely affect. But even if you manually try to send this drone into a restricted area, because you have defined the geofence previously, your onboard flight computer will restrict that drone from going into that space, and it will push it back into an area where the drone is capable of flying. This is, if you imagine a bowling alley with the gutters up, the bowling ball sort of rings in and goes into the center. It doesn't fall into the gutter. That is essentially what geofencing is like. Apart from this, the other fail-safe measure is something like auto landing or a return to home. This usually happens when you have signal lost. A very realistic approach to this would be, in a lot of places, a lot of urban places, such as stadiums, there is a lot of capacity for a rogue drone to enter that area. If you're in a concert, there is a possibility that someone is flying a drone. That entire area is supposed to be a restricted area. So you will often see someone using a ground-based jammer to jam communication between a ground control station and the drone. In such cases, drones usually have a fail-safe feature where they have completely lost control with the ground control station. So they fly back using something called a return to home mode. So they return to where they had taken off from. This is a fail-safe feature that is programmed via a ground control station. And so such safety features is not just about protecting the vehicle, it's also about protecting the people, it's about protecting property, it's about protecting airspace. And like we had mentioned in previous episodes, in a cascading failure, one mistake can lead to something catastrophic. So multiple layers of safety is very important. And this is something that is achieved via ground control stations.
Interesting. So now that we spoke about redundancy and safety, I think the next generalized question for me is, okay, which is going to be my interesting topic to ask you, is regulations. So currently for UAS and for drones, like, is there any regulations that give you like standardized approach to designing a ground control station or a ground station in general? Like, is there any kind of regulations that tell you that the ground control station shall be X, Y, and Z dimensions, or X, Y, and Z functionalities? Or is it all right now, currently, depending upon the stakeholder, it gets done?
Yes. So the answer to this is yes and no.
Okay.
As a systems engineer, I think you would want way more definition than there is in the regulations currently. Very specifically to India, the DGCA still identifies and regulates what a UAS is. In this case, a UAS, or an unmanned aerial system, consists of the unmanned aerial vehicle and its ground control station both.
Okay.
So the DGCA will give you a lot of regulations with respect to communication, with respect to what sort of power system it's supposed to use, where should the setup be, all those sorts of things. But these are much larger viewpoints. The absolute minute details, like what is the dimension of a ground control station, that is something that is purely up to the stakeholder. That is not something that is currently defined by what is the regulation. Even in the defense field, there is a lot of regulation that is coming directly from the customer. There are MIL standards that will tell you about the quality. There are MIL standards that will tell you about how safe a system is supposed to be. But they are not going to accurately define the minute details of how ergonomic a chair for the operator is supposed to be. That is not something that is part of the safety standard.
No, but that's not part of the regulatory needs as well, right? So the regulations will only define what the minimum requirements are, so that there is no harm and damage done to anything else in which this UAS system is operating in, right? So that's where I was coming with this question. So the minutest details will be depending upon the stakeholder and the designer who is designing for the stakeholder, right? It's an agreement between them. They will define requirements based on how the stakeholder wants them, at what level of detail do they want, right? So that's why I think the question is more about regulations. Like, are there any minimum standards that have been set by the DGCA or by the FAA, like, that you know of, basically, for the UAS systems and its operations and the ground stations?
I'm sure there'll be something for like, oh, you can't use these bands for your communication, things like that.
There is something called ISM bands and non-ISM bands. So most of the communication that is supposed to happen on any commercial drones is supposed to happen in the ISM bands. And you will look at most of the rogue drones that are available, what we define as rogue drones. These are mostly operating on non-ISM bands these days. So That is something that Parvesh has rightly
What is a
identified.
rogue
What is
drone?
no? What is an ISM band to begin with? Like, what is ISM?
I do not honestly know what the full
Okay.
form is.
I'm gonna look it up really
You'll
quick.
have
What
to
is a
Google
rogue
this.
drone? Go to what's
Right.
a rogue drone?
A rogue
Like,
drone is
why
something.
would you call it a rogue drone? Like, is it unauthorized? Is it?
Correct. An unauthorized drone that is undertaking some sort of nefarious activity is a
Okay,
rogue
so
drone.
there needs to be a criminal intent. Okay.
Right.
So ISM band stands for industrial, scientific, and medical bands. So basically, those are specific spectrums of or frequencies in which the drones operate for those purposes, which is industrial, scientific, and medical purposes. So basically, civilian uh, frequencies in which they're allowed to operate in. Now, if you operate in anything other than the ISM, then that requires you to either get an approval from the government or the authorities that you're operating in within, maybe because you'll be interfering with another specific frequency range which the government might be using it for their own services, or b you're just like a specific you have built this drone for a specific purpose, which again is approved by the regulations. So yeah.
An
So
example.
when you said rogue drones, maybe they purposefully run on these spectrums or these bands to do any kind of nefarious activities which are not something which are acceptable or approved for.
You are absolutely right in that identification, because as an example, most of the drones that you see in the market right now that can be used for say agriculture or site uh, analysis, like you have geological analysis, you have GIS. uh, most of these drones use 2.4 gigahertz and 5.8 gigahertz to communicate, where telemetry information and signal data is sent on 2.4 gigahertz, and video and image data is sent at 5.8 gigahertz. But then there are a lot of drones that operate at frequencies like, say, 433 gigahertz, megahertz, 433 megahertz, or 600 megahertz, or 800 megahertz. So these frequencies are not really ISM frequencies. These are non-ISM frequencies. And these drones are doing custom communication with these custom chipsets on board. So these are typically used by rogue elements. So that is something that exists as well.
So
Before
let's
we
say
get on to the next thing, sorry, go ahead with your question first.
let's say I take a drone from your company and then fly it around my neighborhood. Is that a rogue drone?
Yes, because you will be breaking the law. If you want to identify whether you can fly a drone, if you're in India, there is a website that you should go to called EGCA and Digital Sky. So Digital Sky is going to give you a live map of the entire country, identifying zones. Zones are divided into red zones, yellow zones, and green zones. Green zones are places where you can fly without taking permission. So this is where you can fly a drone unrestricted without filing a flight plan. This will typically be outskirts of cities, at least 12 to 15 kilometers from any airport. Then you get into a yellow zone where you need to get permission. And then after filing a flight plan, you can fly a drone. And then there is the red zone where you cannot fly a drone at all. Living in Mumbai, I know most of Mumbai is a red zone. You cannot fly a drone anywhere in Mumbai. So similarly for you, I'm pretty sure in Chennai, a lot of places are going to be red zones purely because it is against the law to fly drones next to an airport, fly in urban areas. You have to leave the city. You have to go into outskirt areas, into grounds. That is where you can fly drones.
So basically it's similar to how it's in the US, basically class A, B, C,
Absolutely.
depending upon the airspace and the area that you're in. The drone operations change. But I think also according to FAA, I think the straightforward regulation minimum is you cannot fly above 500 feet in the US unless you are permissible to do it by regulations.
I think
So
it's 400 feet in India.
so it's 400 feet in India. So it's even
Yeah.
less. So yeah, I guess this is where I think the next question comes, right? So are there any like fail safes that you put in your ground station by default so that you don't fly above 400 feet when you're trying to do commercial uh, operations of the UAS? Or is it something which, depending upon what again the scope is, like you let it be and then let the customer get the approvals for his operations?
So yes, fail safes will exist. First of all, GPS itself is one of the biggest fail safes. Most drones have a live tracking feed for what red zones, yellow zones, and green zones are. Very controversially, DJI just a few months ago removed this feature from their drones. So this used to be something that was part of all DJI drones till a few months ago, where once a drone is switched on, it would identify whether it is in a red zone, green zone, or a yellow zone. And if it was in a red zone, no matter how much you tried, it would not take off. This is something that was coded through its remote control, through its ground control station onto the drone. And now it is not there on the system, which is very unfortunate. Uh, at the same time, like I mentioned, geofencing. So the height case that you told me, anything flying above 400 feet, we have that as a geofencing. So the drone, no matter how much thrust you give it, will not cross 400 feet. Once it is approaching 400 feet, it will sort of stabilize and then just hover. It will not go higher because that is something that we've coded onto the ground control station. So
Got it.
geofencing and GPS, two of the most important safety features.
Okay. So, like, just out of curiosity, so DJI drones are also sold across the world, right? Not just in India. So the blue,
Not
sorry, go on.
anymore in India.
Okay,
DJI
got
drones
it.
are now banned as of quite a while now.
Oh, okay, interesting. But like, when you say when you turn on a DJI drone or any drone, depending upon what it is, if they have gotten the ability to be like geofenced for certain regulations, is there then also a chance that the ground station or the drone itself is programmed to, like, understand where its physical location is and then adhere to those regulations over there? Is that how it is
Uh,
operating?
yes, I believe that is the case. Um, but I'll have to confirm this because I again have a lot of experience working with commercial drones in India. When I
Mhm.
was in the US, I was working purely on R&D drones, which had none of these features.
Yeah.
And so I am not aware of this as a regulation.
I mean, I
Uh,
don't blame you for not knowing it also, because I think the regulations for UAS are still getting determined by the regulatory authorities around the world. So it's not very cut and clear, dry, like, how aviation is in terms of most of the regulations. So
But I believe a good solution for this would be, say, if you are an Indian manufacturer and you're manufacturing drones in India for
Mhm.
India, and now you get a huge order, an export order for drones in the US, the software setup for the GCS and the drone that you would give for the models in the US would be slightly different to that in India. And that would have all of the rules and regulations coded into the system for flying in the US. So, in
Mhm.
a way, yes, what you're saying is right. Now, the question would be, if I take a drone that's manufactured in India for India, take it with me while I'm traveling to the US, and then switch it on there, will it still know that it's in the US and now it has to follow the US rules? That is
Mhm.
something I've not actually tried. So I'm not sure what the answer to that question is.
Okay. That could be one of the things that I think could be ideas that they could implement if required.
Right.
Cool. So the last thing that I can think about to ask you is the cybersecurity side of things. So there's a lot of communication happening up and down from the ground station to the drone, but also the ground station's location in which it's kept, the ground station's interaction with other network, things, or even during the data loading of the ground station to update its firmware or software or anything like that. Um, how much of a cybersecurity perspective is taken while designing a ground station?
So this is very relevant to what is happening today. One of the things that I didn't cover while I was telling you about the parts of a ground control station is the software ecosystem and the software customization. Modern GCS platforms often run on a modular software architecture that allows very mission specific plugins. And this is something that can be altered based on what payload is going to be on the drone, such as image recognition plugins can be something that is there for surveillance drones. Weather overlays can be there for something for flight planning. And you can also have something like AI copilots for swarm drones, where it is not just controlling one drone, but multiple drones. So the level of customization in GCS is there, and most of it is done via software. So it is very important that this software is controlled by a cybersecurity layer. And there are regulations. There is a very recent development with militarized drones in India where there is a demand for cybersecurity safety. And there is a new standard that has come out. Till now, we have been following ISO standards and AS standards, but there is also now a cybersecurity standard. I can go more into the detail for this, but I myself am just getting down to studying cybersecurity because this is something that we are now going to use in all of our projects. But yes, cybersecurity is definitely one of the most important things because it has been identified that hacking into a ground control station can definitely take out an aerial system much faster than any commercial anti-drone or counter-drone system that can be launched onto it, whether it is a soft kill or a hard kill system. So this is why ground control stations are important, but also essentially one of the weakest parts of the system.
So, from my perspective, right, cybersecurity has always been a new and novel thing in terms of regulations for aviation, and but it has gained a lot of momentum and it's become a big thing now. I think most of the European regulations and also American like FAA regulations require a proper security like analysis and work done before you even get your next certification for software, for example, or even like the way the operations of the system is done, because I think cybersecurity does not just live in the software and the protocols or like the communication side, but also the operations side of that system. And that's where I think it becomes like, for example, a portable ground station or even a phone becoming a ground station for a drone. If it could be compromised, then you have a drone of X amount of weight and mass becoming a projectile for somebody. So
Exactly.
that's the reason why I think it is a very critical topic to even talk about. Maybe something that we should discuss in the future episodes too. Not just the ground station, but also the drone in itself, the cybersecurity of it.
Another aspect of this entire cybersecurity thing is, given the size of a ground control station, if you are processing massive amounts of data and your ground control station is not this huge room, but rather a small phone, most of this data is going to be stored on a cloud. And this cloud also needs to be protected. Otherwise, all of your data is now public. So in the case of agricultural drones, you will often notice that a ground control station that is coming with an agricultural drone also gives you subscription to a cloud, where all of the waypoints that you're feeding into your drone are stored as a mission on the cloud. So the next time you want to use the same route to put pesticide or water on the same set of crops on the same set of land, you do not have to plan the mission again, but rather you can just download the same mission from a cloud. If this cloud was hacked, then now the location of your farm is known. And there's a whole lot of OSINT that can be used to deduce a lot of details about you. So there is a loss of privacy, there is a loss of security. So protecting clouds is also very important.
Got it. Yeah.
You see, like, what do you think is the future of ground controls? Like, where do you see all this going in terms of new tech?
So see, this is a question that you have to answer in two stages. Why is a GCS important? Is, I believe, the first question, because when we look at any GCS, the most important reason why a GCS exists is because there is human in the loop, right? So there has to be a human-centric design, and there has to be situational awareness, and there has to be error prevention. This is all things that are being done by the human in the loop. The GCS is not something that is a decision maker. It allows the human in the loop to take better decisions. So the future of GCS is that the decision making system has to be faster, it has to be more accurate, and there has to be lesser errors made while decisions are being taken. So uh, to identify who is guiding a drone, how is a drone responding to new data, how is a drone able to connect to its mission goals, how safe is a mission even where things are going wrong. These are all things that a GCS is doing moderately well right now. But in the future, all of this can be done in a faster way, in a more robust way, for slightly more, I would say, a more variety of missions. And at the same time, the GCS should perform equally well. So for the future, these are all things that are very important. And yeah, drones don't really operate in vacuum. They need brains on the ground. So it is important that we have uh, a faster brain, a more accurate brain, and a more robust brain on the ground.
Uh, I would take another approach to what I think should be the future of ground stations or US in general. I think is more regulations too. I feel like the developments and the designings are going like a little bit more than uncontrolled way of like the amount of drone companies that you see around the world. It's like and the regulatory bodies not being able to catch up with the kind of drones that are coming out. I think that's also another thing that should be, I think the framework has to come in parallel while the development of the technology happens. I think the regulatory bodies also have to catch up with them, and I think that
I
should be
think what
something
you're
that
saying is the right thing, because you can see the amount of regulation that exists in civilian travel, right? I feel
yeah.
like that is what the future of ground control stations would be as well. This will become more of a mission management dashboard for multiple drones that are being operated by multiple users, rather than just being a very singular sort of setup where I have a drone and so I have an individual GCS, you have a drone and you have your own GCS. I think there has to be some sort of merging where drones are going to be flying using the same pathways and the
Hmm.
same airspace. So there has to be some sort of mission management dashboard like an ATC.
Yeah.
And since there is going to be more automation, instead of manually flying a drone, operators will supervise fleets of drones. And there is going to be AI suggestions where a machine is going to tell you whether you wish to launch now, whether you wish to adjust flight paths due to winds, or whether there is any unnatural object in the way that wasn't initially in its path. So these are all things that are going to happen slowly in the future. I know that there is research happening on aerial highways where autonomous machines are able to fly in a systematic way through a predefined air path. So that is something that can be done by ground controls in the future. Another thing that we should really consider, like I mentioned previously, is cloud-based and web-based control. Rather than going into very physical prototypes where you are spending money on hardware, uh, let's not look at Pelican cases and big boxes as ground control stations in the future. Completely browser-based GCS platforms, a completely tablet or mobile units where GCS is just restricted to a touchscreen. That is also something with faster computing, with better cloud access. That is also something that can be done. And you could possibly look at you as a pilot in Chennai being able to monitor, control, and audit drone flying in a place like Ladakh, which is near Jammu. So that is
Work from
something that
home.
is available. Exactly. It's going to be work from home. And the way to make this better would be to then integrate VR and AR. And so that way you would have slightly more immersive interfaces rather than looking blankly into a screen. You could have AR overlays. You could have drone pilots wearing smart glasses or VR headsets. And
I think
these
that's
light
already. I think that's already in place, right? VR headsets, like as a POV for
in
drones.
defense, in defense.
Oh, okay. But I
I'm
thought
talking.
I thought I saw some commercial applications of it happen too, like drones being used to follow paragliders or skydivers or something like that. Like
I
maybe
think
I'm
what
not.
you're talking about is FPV goggles.
Yeah, FPV
These
goggles.
are
Yes.
right. So FPV goggles are something that is readily used. These are specifically used for FPV drones, which are these really tiny drones. They have these really small FPV cameras. And so you have an operator wearing FPV goggles, getting that first person view and shooting really tight angles. And that is something that is really interesting, and it's already there. But imagine doing much larger sort of drones with similar viewpoints. So you will have live overlays of terrain. You will have an access to no-fly zones. You can see track moving objects in space at the same time.
Oh,
So things
okay.
like that. So
That would be
what you
crazy. Yeah.
see in movies typically of the future, that is something that can then be integrated as VR and AR into ground control stations.
Nice. Yeah. Okay. Understood.
Thinking of a future, where as a controller, you're sitting and you're saying, okay, turn left. And then the drone talks back to you and says, are you sure? Should I actually turn left? Do you think that's possible?
I feel like AI driven decision making is what we are essentially talking about over here, where your GCS will essentially become your co-pilot. And this will happen
Exactly.
when you have real-time object recognition, if you have predictive alerts, predictive routing, predictive maintenance, if you have flight optimization recommendations, and you have something called automatic anomaly detection, where anything you say, if it is wrong, the AI can prompt you and say, are you sure this is what you want to do?
So 10 years ago, they used to never call it AI, or even like for me, also calling it AI like seems a bit weird, but it was always machine learning, right? Like, and we used to call it like sense and avoid systems when we were doing courses in Riddle, like these automated, what was the term you used? Prevention, sorry, avoidance,
Predictive
predictive.
maintenance.
Yeah. So, sense and avoid systems was what was called at all, like like every time we did any kind of sensors or data links course or something like that, and now it's become a reality. So it's crazy to think about it. So it's already
AI
almost
is
there, I think.
simply like a superset for machine learning. Like
I guess so. Yeah.
machine learning just falls under AI.
Yeah, it does.
So, just in context of how this will help
Mm-hmm.
at present and in the future, in both cases, you are going to have human in the loop. That is just simply not going to go away.
Mm-hmm.
Right now, what's happening is the machine is throwing up a lot of data onto your screen. You are analyzing the data and taking a decision. In the future, you will have AI that is going to analyze this data for you, and you will be able to take a better decision. So the overall time taken to make a decision drastically reduces. And you are able to train AI and use ML to identify patterns in the data and get to a deductive result at a much faster rate. Having said that, there are always anomalies to every situation. And this is the reason why humans will always be in the loop. You cannot expect AI to start taking decisions completely, because then there is a moral and ethical dilemma as well as some legal implications. So that is how
That
exactly you would
episode.
say.
Yeah,
Probably,
AI
probably.
in aviation would be another episode. Yeah, that would be a different topic to explore.
It'll be a crazy episode.
Yeah.
But then there is always a lot of advantage of using systems like this, especially in the case of how we thought of, rather than identifying single drone users with their single ground control stations. If you have multiple operators with multiple ground control stations, you can start looking at something that airplanes do right now, where you have an ATC that is handing off airplanes onto a different ATC. This can now, a seamless handoff can be taken care of by multiple GCS for a drone that is going into a beyond visual line of sight sort of path, where you can take over this drone, I can take care of this drone. This sort of communication that can happen between ground control stations. This is the sort of future we are aiming at. And you can then integrate command and control systems with other data, other metadata, such as weather feeds, such as satellite imagery. And then
GPS.
using that, you can start communicating with other ground control stations. And this would be perfect for any complex disaster response or a military coordination over a larger sort of country sort of level. So that is, again, looking to the future, a really interesting part of ground control stations.
Yeah, that's exciting, and I think we should also explore that in like future episodes too, like how this impacts the whole ecosystem. All right, so any closing notes, guys? Anything? How did you feel about this episode?
I learned a lot.
Not a lot. All right. All right, let's
Because
close it
most
off
of
then.
my work is business related and engine related. So learning about drones is new for me.
Okay. All right, so let's close it off. So thank you guys for watching this episode. I hope you guys
See
liked
you.
and enjoyed today's topic. Please do share your thoughts on our topic today down in the comments below. Please do like, share, and subscribe to our videos, and to our reels and our shorts that we are actually posting on a constant basis. Also, make sure that whatever streaming platform you are using, Apple Podcasts or Spotify or Amazon Music, please do make sure to give us a 5-star rating for it, because it does help us to get some visibility and actually put us up there for future episodes too. So yeah, thank you so much.
Just to add to this, if you've taken anything away from the episode today, we are Ground Control. We are uplinking our episodes to you, to all of the major nerds. We're just waiting for some downlink to come from you guys. So we are hoping to hear from you guys soon.
With that being said, we would sign off now for this episode. Thank you guys for listening in. See ya.
Thank you. Bye.